introduce the sixth trigonometric function, okay? So I just recall what you got to know so far is this one, okay? Recall that if a right triangle, if a right triangle is given, okay, that is going to be the case. Okay, that's going to be the angle. That's a right triangle, and usually call this one alpha and this one beta if you like. And we go with the A, B, and C. Okay, so there is a relationship between these sides, the Pythagorean identity. So you must know that the A squared plus B squared is equal to the C squared. And we're going to use it tonight, okay? And there is a relationship between the angles. Alpha plus beta is equal to the 90 degrees. So they are complementary angles. Then we introduce the sixth trigonometric function. We go with the sine. Sine of alpha is just the opposite side, B, over the hypotenuse, the largest side, C. That's a sine. So cosine of alpha is going to be adjacent side, which is going to be A, over the hypotenuse, which is going to be C. Then we get the tangent. We can divide the sine by cosine, or tangent is going to be the opposite side over the adjacent one. So that's a three famous function that we introduce. Okay, then we have a reciprocal functions, if you like. Reciprocal of a sine is called, okay, cosecant. So cosecant of alpha is 1 over sine of alpha. So in this case, it's C over B, if you like. You don't need, as soon as you got this one, we flip it. And then we introduce the secant. Secant of alpha is going to be 1 over cosine of alpha, okay? In this case, it's going to be C over, you don't have to memorize this one. And cotan, okay, that's it. Cotan of alpha is going to be 1 over 10. There is a condition for here that, you know that this, for example, the sine of the alpha is not going to be 0, and the other one, we know that. So this is what we did so far, all these sections. And the first four problems or 3 problems in your practice quiz are going to be covering by these conditions, okay? So some of these would be given to the ask for the others. This is what we did. So quickly, any question? Now, quickly, I'm going to use it in order to cover the section 1.5. You see, in 1.5, some of this information would be given to you. You have to find the others. You see, in the case of the right triangle, we have 3 sides, A, B, C, and we have 3 angles. So if a right triangle is given to you, and you be able to give us A, B, C, and the alpha and the beta, in this case, you are going to tell us that you solved the triangle. Okay, solving a triangle is going to be one important problem in this course. At the end of the course, we can solve any triangle, but for the time being, we can only solve a right triangle. So one of the questions on your quiz is going to be this one. Okay, so some of this information would be given, they ask for the others. Okay, it's a kind of 3 cases, but it's a general case. You don't have to memorize anything. You'll be able to find it for us, okay? So this is it. This is section 1.5. We're going to use exactly those information to take care of this section. This section, the topics is going to be solving. Okay, solving a right triangle. In future, we solve any triangle, of course. Right triangle. Okay, what does it mean? This means you have to find all the information. So that's the instruction to solve. Okay, to solve a triangle, a right triangle or triangle in general means, okay, means to find the measure of the angles, to find, okay, to measure of the three angles. Okay, that's it, of the three angles and three sides and three, okay, three side length, if you like, length of the triangle. So if they ask you to solve the triangle, this is what they mean. You have to find all those quantity for us. For the time being, we go with the, okay, we go with the right triangle. But when we get towards the end of the course, right at the end, we are going to see any, okay, any arbitrary triangle. Okay, and this is your job. You are going to use these, okay, these formulas to be able to find it. Depends on the situation you're going to have. It's a kind of two cases. Basically, the case is, so I give you example and I tell you what cases are going to have. Okay, the first case is going to be one of these angle, alpha or beta, would be given to, and one of these, okay, side length. So the example is going to be, we would like you to solve, okay, solve each right triangle, We give you one question, but two cases for the quiz, and then we repeat it again on your next test number 1. Okay, so we are going to see the case 1. Okay, the case 1 is going to be the following. Okay, we usually give you the graph of a triangle so that it's not going to be, you're not going to miss anything. Okay, this is it. So this is as usual the A and the B that we talk about it. You can use other symbols if you like. This side is given, it's going to be 15 feet. Okay, and this angle is given here. This angle is given and they call it 56. Okay, 56. So the information would be given as follows. C is given to you, which is a 15 feet. Okay, and one of these angle alpha is 56 degrees. Okay, they call it case 1 because you have an acute angle. Okay, one acute angle and one side is given to you in this case. Okay, so this is all the information that we have. So what you need to find is this one. You have to find this angle and you have to find these sides here. Okay, are you ready? Okay, any suggestion? To go for it. For the angle first.
Do 90 minus 56.
Excellent, that's it.
We will find.
Okay, so it's going to be 90. We call it beta if you like. You see the beta is going to be 90 degrees minus 56 degree. Okay, so that gives us what? 34, yes. That's a 34 degrees. So we are done with the angles.
Yes.
Okay, that's first part.
We will
No.
find.
Okay.
We will find the sign of 56.
Yeah, we check to see which one is going to be possible.
Yes, the sign.
See, that's it, yes. Because you see you have the hypotenuse over here. So if you use the sine, for example, the sine of the 56, remember, is going to be the opposite side, B over C. So we have the 56 and the 15, we can find the B. Okay, and then we can use the cosine if you like to find the other ones.
Yes.
Okay, so this is it. We go with the sine. Okay, this the sine of the 56 degrees is going to be equal to the B over C, B over 15. Okay, if you cross multiply, B would be equal to the 15 times sine of the 56 degrees. Okay, then use your calculator to find these numbers. Okay, we already talked about it, how we're going to use the calculator. They are not going to be exact in the case of the right triangle. Okay, and you know that's just easy calculator. We do it for you. Okay, this is it. This is the one that I have. So I go with the sine first. Make sure that it's on degrees. So this is the sine of the 56. 56, this is the sine. And if you like, you know, this is going to be 0.8 multiplied by 15 to give you the final answer. Okay, so the final answer would be, I write it down so to explain something. So this is it. I put it on the top. You see this B with the calculator is going to be 12 point, you know, it's the first one I want to explain. 4, 3, for example, 5, 5, 6. Now we are going to run this one, these numbers. In your book, they call it, they talk about something they call it significant digits, but basically the way we are going to do it, we just check to see these numbers. You see 15 have 2 digits, or the 56 have 2 digits. When you want to run that, the number of the digits that officially or generally, the number of the digits that you are allowed to have, it must be the same as the minimum number of the digits in the given information.
Oh.
So in this given information, you have 2 digits only. Okay, since you have 2 digits, so you have to run this one so that you are going to have only 2 non-zero digits. Okay, so that is why you are going to, okay, for the 2 digits, you are going to run that to the whole number part. So in this case, B is going to be, the final answer in this case is going to be equal to the 12th. Okay, or just run that, you know, to the whole integers if you like. We are not going to be picky about this one because in your book they use different idea, but that's a general case. So the minimum number of the digits that we have is going to be 1 and 5. So we run that and we call it 12 bit. Unless some instruction is given to you about the rounding, you can follow this, okay, this procedure if you like. Okay, so we have the B, then you have 2 choices. You can use particular identity to get the A, or you can go with the cosine. Okay, the cosine is easier. So I go with the cosine of the 56 degrees. Okay, and the cosine, you know that the cosine is going to be adjacent, which is going to be A over 15. Okay, just use cross multiplication. So that gives you 15 cosine of 56 degrees. Again, you can use your calculator to get this number. So the number is going to be, if you want to see it, it's, if you multiply them together, you arrive at 8 point, something like 38, okay, 78, 9. You don't have to write it down. On the test, you can use your calculator to give us the answer. We accept it right away. And now, so this is going to be the case. But remember, you are going to use 2 digits, 2 significant digits over here is 8.3, okay? So what you have to do, you have to run that to the, over here, run that to the 10th place so that you are going to get only 2 digits. So in this case, A would be equal to the 8.4 as the final answer. Okay, this is the general instruction for rounding in this section 1.5. Okay, any question? So that's a
Yes.
case one. Yes, question.
Is it possible to use calculator over phone?
Using what?
Calculator over the phone?
Yes.
Oh, in the exam?
In the exam, you know, you need your phone for there to be on Zoom. You better use a calculator yourself. No, not cell phone.
Okay, right.
You know, just
Thank you.
so you know, ordinary calculator would do it for you. Really, that's it. Okay, you don't need any fancy one, but you need a calculator quite a lot for this course. Okay, any question? So a straightforward case is really in this case one. So an angle and a side is given to you. They may switch the sides into different format. This is case one, and we have one on that practice one. But we usually give you two parts for this problem. Okay, so the other type is going to be this one. Okay, so that was example number one. This is going to be number two. In example number two, in this case, two sides would be given to you. You want to solve. Okay, that's it. So what's going to be case two? The case two, this is the given information. Okay, that's it. So the only thing that you have the hypotenuse is given to. This is 23.5. Okay, 5 inches, miles. In this case, is a mile. And over here, this is 17.2. 7.2. So this is all you have. Okay, so two sides are given to you. Two sides are given to you in this case. So the information that you have to provide is going to be the angles. Okay, and of course, this one over here, if you want, A is missing. Okay, so this is going to be a situation that we are going to have for this number. Okay, any suggestion? So if you like the alpha is missing and the beta is missing to find it.
Quadratic formula?
Yes, let's say.
Oh, Pythagorean, sorry.
You can go with the yes, we can go with the Pythagorean to find yes, because we need this side to find it. We can use the Pythagorean identity, yes, to find the other sides. So we know that the a squared plus b squared is equal to the c squared. Okay, now we are going to substitute. A is the missing one. So this is going to be, this is b usually, 17.2 squared. And this is 23.5 squared. Okay, so you can use your calculator to get this number. So it's a squared plus, I have 295, okay, 0.84 for this one. And the other one is 552, sorry, 2.5. Again, the calculator will give us the result right away, we accept it. So we have to subtract 295.84. Okay, so the a squared is going to be 256.41. And you take the square root. If you take the square root, a would be, okay, I have 16. I have 16.01. 16.01, but as you can see, you are using 3 digits only. So you have to run that to write it down as, okay, if you run that to get that 3 digits, you see this is going to be equal to the 16.0. If you go with this instruction of your book, you have to write that 0 to show that you are using 3 digits. Okay, when the problem is going to be a problem in science, this would mean something that would give us a message and they understand it. Okay, you have 3 digits. You see 1, 2, 3, 1, 2, 3. The minimum number of the digits is 3. So you have to give us a result with this format. So I run that to the 10th place, and the result is 16. But we write it down as 16.0 to show that it's consistent with the number of the significant digits that we have over here. Okay, any question? So you have the A. How about the angle? We need to find one of
Sign. We
these.
have to make sign.
Okay, we can make sign. Yeah, we have all of them. We have
Yes.
the, okay, I go with the, okay, sine or cosine. I have the cosine, so I go with the cosine. Okay, so this is going to be alpha. You can go with the sine as well because you have the all the points. Okay, over here. Okay, so this is going to be the case. Let me see. I have the 17.2, and that's 23 point. Yes, we go with the, yeah, we can go with the, yeah, we can go with the sign. So what's going to be the sign? The sign is going to be sine of alpha is equal to, okay, it's going to be equal to what? It's going to be the opposite, which is 17.2 over the adjacent, which is 23.5. Okay, so this is it. So if you divide this one using your calculator, so that give you the sine of alpha is equal to, you can check it, but I have 0.73191. Okay, that's going to be the sine. In order to find that, we are going to talk about the sine inverse, okay, through the final exam. But for the time being, we can use, we have no other choice. We can use the calculator to get the opposite, if you like. We call it the inverse in future, to get this number. You see in your calculator, whenever you have the sine, if you go to the second operation, that gives a sine inverse. And this is cosine, then we get the inverse. Okay, inverse means you are interested to find, you see over here, you are interested in finding an angle whose sine is this number. Okay, so the sine is given, you want to go back to the angle. We are going to give you this one in full detail later. So this means this is how we're going to go back. So the alpha would be the sine inverse of 0.73191. Okay, so you can do this one for the sine, cosine, tangent. So what you do is you go to your calculator. Okay, in order to get this sine inverse, you have to go with the second. Okay, and then you put on the sine that give you the sine inverse. Okay, it's going to be sine inverse. The number that we have is, what is that? It's going to be we have 73191 and equal to. So that give you the angle in question. Okay, so it's almost 47.046. And what we are going to do is we are going to run that using 3 decimal places. Okay, so if you run that, so that give you just 47. Okay, so 47. Okay, to use the 3. And so yes, it's going to be 47 as your angle. Okay, so I write it down so that you know that we did run that. It's a 37.0467, but we run that. So the alpha is going to be 47. Since they use the three digits, so you put the 0 here just to show that you know that you are going to have, to show that you did run that to get these numbers. Okay, any question?
No.
So we have the alpha, now we are ready to get the other one. Okay, the other angle is going to be easy. So the beta would be 90 minus 47. Okay, so the 90 47, that gives us 43. So we have the beta, which is 43, and then we're done. Okay, so it's not a difficult operation, but since you have to use your calculator, you got to be careful to make sure you get these numbers, okay, on the right direction. Okay, any question?
No.
So we are going to use it from time to time in different problems. This idea of a right triangle. So I have one of the examples like the one that we did or we have. We give you one application problems, okay, for these type of problems. It's an easy one. Use it in calculus, just in fact, we use the second one. In calculus, the tangent is more popular. So we didn't use the tangent here. So this is the problem that you need to use tangent, okay? So we give you one application problems for the right triangle. So we get 2 questions on the right triangle on the quiz, 2 out of those 6. So this section is important for us. Okay, what is this problem? It's very similar to that practice one. We want to find the angle of elevation. The angle, this expression is going to be used quite a lot. Okay, elevation of what? Of the sun. If a for the 8.6 feet flagpole. Okay, flagpole cast that cast a shadow. Okay, cast a shadow of 63.1 feet long. Okay, that's a very popular problem. You have a flag. You see that's you have to have a graph, if you like, of information. So this is going to be the flag. Okay, this is the flagpole. Okay, this is the flagpole, and this is going to be the shadow.
Oh, shadow, yes.
Okay, this is it. So that's going to be the shadow. Okay, in the case of the flag, the length is 48. Okay, it's 48.6 feet, and the shadow is 63. Okay, 0.1 feet. This angle, you see, this angle is going to be called, that's an elevation angle. We call it alpha or theta. It doesn't matter. It's usually we call it theta. So it's going to be the angle. Okay, you see the sun is somewhere here. So this is going to be the sun, if you like. Okay, and this is the way you get that shadow. Okay, it's very popular problem. And so you have to find the data. It's a right triangle, so you have to decide which formula is going to be good for this one. Any suggestion? Which of those functions? Sine, cosine, tangent?
Tangent. We find tangent.
Tangent. You see the information?
Yes. And
The information is the opposite side and the adjacent one. You don't have any information for the hypotenuse, so you cannot use the sine or you cannot use the cosine. I mean, you can find it, but just think about which one is quick to be able to find it. So the quickest one is tangent,
Tangent,
because we
yes.
have the opposite and the adjacent one, okay?
Mhm.
So, and the information are all given, so we use the tangent to get it, okay? So we have it in calculus is going to be, it's a very similar one, the one that we use over there for the tangent. This is a sun. We talk about the lighthouse something. Then it's very similar. Okay, so that's it. With this information, we know that we have to use the tangent. So I'm going to write it down here so we can see it. So you have to use the tangent of theta. The tangent is going to be the opposites over the adjacent. So the opposite is 48. okay, 48.6, and the adjacent one is 63.1. Again, you have to use calculator to get this number. So if you use your calculator, you can do all of them at the same time. Even you don't have to write it down for us, but this is going to be the calculator. I want you to see it. So to get the tangent, you have to find the, okay, you want to find an angle whose tangent is given to you. You have to go to that operation and find the operation of a tan inverse, okay? Inverse operation. So that's going to be 0.770206. So you go to your calculator, okay? You go to your calculator, you go with the, okay, I turn it on. So I go to the second again, then you click on tangent this time. So that give you tan inverse. Tan inverse of what? Point, okay, 0.77770206. Okay, if you click, so that give you see that's 37, that's the 37.603. You know that you are going to use three, this, okay, 3 digits only, so that's going to be 37.6. Okay, so the data that you're going to use is going to be 37.6 degrees. So that would be the, okay, elevation angle, if you like, to get these numbers. Okay, any question? So we have two problems in your practice one that we do it, and you'll be fine with this right triangle. The right triangle is easy to solve. For the ordinary triangle, we have two famous formula. One of them is called sine formula, sine law, cosine line, but we cannot talk about it now. We talk about it, through the end of the course. And there is a formula, we can use it in order to get the area of a triangle. So that's it. Any question?
No.
So we are done with chapter 1. So what we did in chapter 1, we just stay with the right triangle. Okay, we stay with the right triangle on our formula. So what we are going to do is we would like to able to introduce this 6 trigonometric function for larger angles. Okay, so because this is just the acute angle that you're going to use. So what we are going to do is we are going to get these angles out of the right triangle. Okay, instead of the right triangle, we can use the XY coordinates. Okay, XY coordinate and talk about the angle over there. Okay, so if you locate your angle on the XY coordinates, for which you know that an angle would have what? Would have a vertex, and we have an initial side and the terminal side. So if you go to the XY coordinate, into the XY coordinate, and you check, you start with your initial side is going to be x-axis. X-axis, so the vertex would be at the origin. So if you give us the angle using the XY coordinate, we say that angle is in standard positions. Okay, so we go out of the right triangle, we introduce the angles in general, and then we come back and we see that quickly we get back to this right triangle version. You see, at the end of the day, especially for calculus, really, this is the only one that you need, a right triangle version. But in order to get the formulas, so we have to generalize the theorems. But at the end of the day, that's all we need. So get to know this right triangle. Okay, 2.1 is just introduction of bigger angles. Okay, so we are going to introduce the angles in a standard position, so we have to know it. So what is or where are we going to call these angles? Angles. Okay, angles in standard position. A standard position. That will help us to get out of the right triangle, but you will see in a minute and we come back again. Okay, so an angle is going to be a standard position if its centered, if you like, vertex at the origin, and the initial side is going to be on the x-axis. Okay, so I give you definition. An angle. Okay, that's it. An angle is said to be. Angle is said to be in a standard position. Okay, standard position. The standard position if it's initial side. Okay, initial side must be the x-axis. Initial side, okay, is going to be along. It's going to be along the positive x-axis. The positive. Okay, the positive x-axis, and its vertex must be at the origin. Okay, its vertex is at the going to be at the origin. So that would enable us to have a larger angles. We're not going to stay with the acute angle. Okay, so this is going to be the standard. So that's going to be this is the XY coordinate, if you like. You see, that's the XY coordinate. And if you want to introduce an angle, you start from the initial side over here, and you get to the terminal sides. Okay, so this is going to be the angle. Okay, the angle alpha, theta, whatever it is. Okay, so it's in a standard. If you start from the initial side, it's going to be the positive part of the x-axis, and you go to your terminal sides. So that would be angle in a position. And since now we can go around, okay, we can go around. It's like a complete cycle. So that gives us that 360 degrees rather than the one that you have in the case of the right triangle. Even we can go around twice. If you go twice, that gives even 720 degrees. So we can introduce larger angles. Okay, so let's get some of them. Your job is just locating these angles. You see, just introducing various format that we're going to have. You see the first one, if your angle is equal to the, for example, 30 degrees, and this is going to be the location of the 30 degrees. Okay, this is it. So we're going to denote the 30 degrees. Okay, this is going to be the way we denote the 30 degrees. Okay, that would be 30 degrees if you can see it. Okay, it's going to be in the first quadrant. Okay, the first quadrant, you start with the 0, you get to the 90 degrees. Okay, 90 degrees and 180, 180, 270, and 270 and 360. We're going to get to that one in a minute. Okay, let's have a different version. So the next one is you have 135 degrees. Okay, so 135 degrees is going to be this one. So we start with the 0, you see it's going to be the 0 degree, 90 degrees. This is 180. So it's going to be something in the middle. Okay, this is going to be in the middle. So your angle is start from here. So this angle would represent by 135 degrees. So the terminal, it would be terminated in the second quadrant. Okay, second quadrant. This is the first quadrant. And that would be important for us in a minute. Question. Let's have another one. I'd like to get to the, okay, to the third quadrant. So it's a 220 degrees. So we get to the 180 here. So 45 degree more. So this is going to be the situation that we're going to have. Okay, 45 more. So this is it. So this is going to be the 45. And so this is going to be your angle. So this angle is going to be 220 degrees. And it terminated in the third quadrant. Okay, the first, the second, the third. We need one more. So to get to the fourth one, something like 330 degrees, to show that we can identify any angle you like. So this is it, the 0, 90, 180, okay, that 270. So this is 300, this is 360. So it's going to be okay, so there you are, 90, 80, 270. Then you have to go on 60 more if you like to get this part. Okay, so this is going to be your angle. You start from here and you end up here. So this angle would be represented by 330 degrees, and it's terminated in the fourth quadrant if you like. Okay, any question? Now these are the positive angles. We can have the negative angles at the same time. Remember, for the negative angles, the direction would be opposite. So in this case, I write one here so that we have all of them together. So for example, if you have a negative 45 degrees, so you have to change your direction. The initial side would be the x-axis, but you are not going to go counterclockwise if you like. So it's going to be, so this is it. So you have to start from this direction. So you start from this direction and you end up here. So this is going to be your negative 45 degrees. Okay, so this would help us quite a lot. To be able to identify, okay, to be able to identify larger angles. You see positive, negative, whatever you like, to get these numbers. Okay, and you know that this is, you go around once, that give you 360 degrees. But you have to more, then you may have to continue. So you may get some angles that would end up with the same terminal sides. Okay, you know, the expression is co-terminals angles, but we get to that. It's just the meaning is as is. Okay, the co-terminals. They are going to be important for us when we get to the other chapters, if you like. But for the time being, it's not going to be a big deal to get these numbers. Okay, so this is going to be the case. The case that if you have something, above, for example, 360 degrees. So if you have something like, let's say, 405. So when you go around, so that gives it 360. Then you have to come back here 45 degrees. So the terminal sides, okay, and of this angle and the 45 degrees would be the same. And then later on, we are going to have a nice information about it, that we can shrink the angle and just using those coterminal ones. But that will be talked about later. So we don't need anything else for the standard position. Any question? The problem in this section, we just ask you to locate it. Nothing, and nothing more bad. And that would enable us to go to the important section, which is 2.2.2. Now what's in 2.2? So now you got the angles in these positions. Okay, you are out of the right triangle. Now how are we going to define those 6 trigonometric functions for this type of angles? Okay, very easy to define. We change it quickly into that format that we have. Okay, so the reason that we introduced this standard position is to be able to extend the concept. So now we are ready. We are ready to give you the 6 trigonometric function of any angles you like. So that's the topics of that covered in 2.2. Very interesting and important one. Okay, what is this? So how we're going to define a trig function? Okay, trigonometric metric functions of any angle of okay any angle. So no restriction. The other one we were restricted to the right triangle, but not anymore. Now, how are we going to do it? You see, the point is that if an angle would be given here, let's just write it down, then I give you the information. You see, consider this one. This is going to be the XY coordinate. Okay, XY coordinate. Now we know that we can identify any angle. Okay, so pick any angle you like. Okay, suppose suppose you pick this angle. Okay, so this is the one that you are interested in. So what we are going to do is we are interested in. So this angle would be the angle theta. Okay, it's going to be the angle theta, and it's terminated into the first quadrant. Okay, so this angle is given to you. So what you are going to do is, in order to get that 6 trigonometric functions, just pick any point you like. Pick any point you like on the terminal sides of this angle. Okay, any point. So I'm going to pick this point. Okay, it's optional, but you must be in the first quadrant. Okay, so I pick a point. I'm going to call this point the point P. Okay, it's optional. So a point would have an X and the Y coordinate. Okay, so this point would have the X coordinate, which is this one. Okay, so this distance over here is going to be X. Okay, and this point would have a Y coordinate. Okay, and this is going to be the Y coordinate, which is equal to Y. Okay, when this is going to be equal to the Y, so this means this portion is equal to, okay, this portion is equal to Y, which is the same as, okay, the same as this part. So this is what I have. And remember, this is going to be a right triangle. That's it. You see? So this would be a right triangle. In the case of the right triangle, I can define that 6 okay, trigonometric function that we did before. And so I can define the sine. If you want to find a sine, it's going to be the opposite side, which is y over the hypotenuse. Let's find out what's going to be this one. We can use the right triangle, particular identity. So we are going to call this one R. Okay, we call this one R, and we are able to find it. What's going to be R? X squared, you see? X squared plus Y squared is equal to the R squared. So we can easily find the R. We find the R, which is going to be what? R is going to be X squared plus Y squared. We assume that this R is not equal to the 0. Okay, otherwise, yeah, your angle is not a 0 angle in this case. Okay, so now we are ready. We are ready to define the, okay, to define that 6 trigonometric function that we're going to be interested in. So what's going to be the sine? Sine would be Y over R. Okay, and we remember that this is Y coordinate, if you like, Y on the Y axis. Okay, so the sine of the theta would be Y over R. Cosine would be X over R. What's going to be tangent? You know that the opposite over the adjacent is Y over X. How about the others? Use the reciprocal and you're done. Okay, so that gives us quite a nice information to be able to do it. When we get to the next chapter, we are going to make this one a special. We are going to have a unit circle version. It's going to be the situation that R is equal to 1. If R is equal to the 1, so the sine of theta would be Y, and the cosine of the theta would be X. But we do it, that's the next step. Okay, so quickly we are able to define the 6 trigonometric function, but this point P is going to be important. Okay, so sometimes the point P, of course, the point P would be given to you, and sometimes you can pick that point If it's going to be a special one, you have to pick that point yourself. Okay, so this is it. So officially, we are ready to give you the definition of for any angle. Okay, so let's take. Okay, this is it. Let's say if data is any given, okay, is any given angle, but in a standard position. Okay, standard position. That's it. Okay, with a point. It's going to be a point P equal to the x comma y. Okay, that's associated to this point angle or just correspond to this. Okay, with the point P equal to the x y on its terminal side. Okay, it's going to be on the terminal side such that, okay, we just impose this condition such that, as I showed over here, r equal to the x squared plus y squared is not equal to the 0. Okay, if this is going to be the case, then we are ready to define the sixth trigonometric function. Okay, if it's going to be the case, then the sixth trigonometric, okay, trigonometric functions of theta, or theta are going to be defined by, like the triangle that we have. There we are. We can define those three first. Okay, the sign of the data is going to be, the opposite is y over r. That's it. Then we can define the cosine. The cosine of the data is adjacent one, which is x over r. And the tan, you divide these two, y over x. Okay, the tan of the data is going to be y over x. That's it. Then you know that the others can be defined just using the reciprocal. Okay, so the other one are going to be 3. So if you want to define the cosecant, we find this one and we just use the reciprocal. So it's going to be r over y. Of course, you have to impose the condition in this case that the y is not equal to the 0. Then the opposite of the inverse of the cosine would be secant. So that gives you r over x. Again, x is not equal to the 0. And we get the cotan. Cotan of theta is going to be x over y when y is not equal to 0. So we usually find the first 3, and then that's it. We change it into the reciprocal. That's it. This is how we extend the idea. Okay, the idea from a right triangle. That's why we study right triangle first, because we need the right triangle. Okay, we write triangle and then get these numbers, and then we're done. Okay, your job is, this corresponding point would be given, and they ask for the 6 trigonometric functions associated with the given point. We give you one on the quiz and on your first test. Okay, so let's see what's going to be the possibilities. Any question? Just get to know the formula. Anytime you forget it, just write your side. You see the right triangle and just use the same thing. The difference is going to be that this angle is in a standard position. So the angle can be in the first quadrant, the second, the third. So these x and the y's can be positive or negative. In the case of the right triangle, it's just the length. Okay, it's side length, you assume it to be positive. But you have to impose those negative sign. You can do it carefully, but it's going to be the same thing. Okay. So that's it. 1 point would be given, and then they ask for it. This is it. So they are going to tell you that, they give you the instruction. They tell you that the terminal, okay, the terminal side of an angle data in standard, okay, in a standard position, passes through different ways, to express this, but passes through the point, okay, the point 3,7. Okay, this is the one version. The other version is, it said let 3 and 7 to be a point on the terminal sides of the data, but you understand that what they are talking about. Okay, so that's it. We want to find the 6. Okay, find the exact, means no calculator, the exact values. Okay, exact value of the 6 trig function, of the 6 trigonometric functions of data. That's it. So if you like, you can locate the point. It's going to be useful for future. It's in first quadrant, so nothing to worry about regarding those signs. You see, this is going to be something like 3 and 7. So this is the point P. It's the point P, and this is going to be okay. This is 3, and this is 7. That's it. You have to find the R first to get this information. Okay. So, are you ready? Solution. Get the R first. The point P is, you see, remind yourself that the point is at 3 and 7. So X is equal to 3 and the Y is equal to the 7. Get the R and the right information right away. So the R is going to be equal to, okay, 3 squared plus 7 squared, which is going to be 9 plus 49 is going to be radical 58. Since they say exact, you are not going to change it into anything. You just keep it as is. Okay. So just keep it as a radical. And so start writing those information, then you're done. Okay, it's like, you have a right triangle. You see, you have this right triangle. This is going to be your points. So that's a 3, that's 7, and this is a radical 58. And you want to write your information. Okay, so that's it. The sign of data is y over r. If you like the formula, this is going to be 7 over radical 58. You cannot leave it because they ask for the exact. You know that you multiply the top and the bottom by radical 58. So that gives you 7 radical 58 over 58. When they say exact, you have to go this far. You have to simplify that radical for us, remember. Okay, that's a sign. Any question? Cosine? You see it from here, you see the cosine. Adjacent one, if you like the formula, x over r, then your substitute is going to be 3 over radical 58. Then you have to, okay, rationalize it. So that give you the cosine. Okay. Then you know that the tangent you divide, or just you sit here at the tangent. Okay, so the tan is going to be y over x, which is 7/3. So that's going to be the sine. Then use the reciprocal to get the others. Okay, reciprocal of the sine would be cosecant. Cosecant of the data. Okay, use this one so that you are not going to rationalize it. So that's going to be radical 58/7. So that's going to be cosecant. Secant, the reciprocal of the cosine. Okay, so that gives you radical 58/3. And the cotan is the reciprocal of the tan. So the cotan is going to be 3/7. And you're done. Okay, not a big deal. Nicely done. The only point is I have to give another one because when the point is going to be in the first quadrant, this is exactly the way we did it for the right triangle. Okay, but if it's going to be in the other quadrant, you got to be careful. The way the way you want to operate. If you want to use XY XYR as is, nothing to worry about. Let me just give you another one. Any question? So it's going to be easy procedure because that takes us back to what we did for the right triangle. When the signs are different, just be careful. There is a kind of converse problem. I'll talk about that one in a minute. Okay, so let's check this one. Another one. The other one is they give another point just in the second quadrant. So we are going to suppose, okay, suppose the point -3 and 4 is going to be, this is a point, is going to be a point on the terminal side. They have to tell you this expression, terminal side of the, okay, of the angle theta. That's it. So we want to find the sixth trigonometric function. So we'd like you to find, okay, find the sixth trig function. Six trigonometric, okay, metric functions of data. See it? You see the point is in the second quadrant. Okay, so the solution is going to be, so if you like, you don't have to write, but it's nice to know it's a -3. So this is going to be a -3, and that's 4. Okay, that's 4. So this is going to be the point P in this case. Okay, this is going to be the point P. Then the same situation that we did have. Okay, for this one, you see you start. So the angle is, okay, this is going to be the angle theta, if you like. Okay, in this case, this is going to be the angle theta. But the information that we are going to have is going to be the same thing. We have to find the R. Okay, this is again the angle would be represented by those information that we have. Okay, we have to find the R. The same thing. Okay, so what is going to be? So x is equal to the -3. Okay, x is equal to the -3 and y is equal to 4. So we go for the R. So the R is going to be the square root of -3 squared plus 4 squared. Okay, so that gives me 9 and 16. Radical 25. So R would be 5 in this case. Okay, so this is going to be the case that we have. Okay, so now we are ready to give you the formula. So the sign of the data, the sign is YR. Okay, the Y is 4 to get the 4. Okay, 4/5. This is going to be the sign. The cosine is XR, so that give a negative 3/5. It's a negative. Okay, then the tan, you divide these two, are just going to be YX, which is going to be 4, okay, negative 4/3 if you like, that's it. And then use the reciprocal to get the other one. So that's easy. Cosecant of the data is going to be 5/4. And the secant of data is going to be negative 5/3. And the cotan of data is going to be negative 3/4. And then you done. Okay, so just use the formula. It's not going to be a big deal. Any question? Now, you have one problem in your book that they do it just a little bit. This problem is important. I put it on the practice quiz, so we may ask you to do it. We can use this idea to find you see, these are going to be, this is the angle 0. If you end up here, this is going to be 90. Okay, so the terminal side of the 0 is here, angle 0. The terminal side of the 90 degrees is this one, just the y coordinate. If you go with 180, this is going to be the terminal sides, 270 and the 360. So they ask, it's a very famous problem that we can use this. You see, in these problems, these points are given to you. So on those special angles, you can pick the point yourself. So you must know it. We may ask you to do this one. Okay, so this example, you got to know. Okay, it's nice to know the application. So we want to find the 6 trigonometric functions of they call it the quadrant angles. So 0, 90, 180, and 270. Okay, so I'm going to find it. I just explain it. So we'd like to evaluate. Okay, evaluate the 6 trigonometric function. The 6 trigonometric and metric functions. Metric functions of the 4. Okay, the 4 quadrant. Okay, quadrant angles. They are going to be 0, 90 degrees, okay, 180 degrees, and 270 degrees. These are called, quadrant. See, 0, 90, 180, 270. And if you come back, you get to the 360 again. Okay, so for each one of them, you have to pick a point P yourself because the point P is not given to you, okay? You have to pick a point P yourself and then use that one to be able to find the 6 trigonometric one. See, this is going to be the solution. We are going to do the 0 first. Okay, this is take the data to be equal to the 0 degree. You see, you identify it to see what are you going to do, what are you going to pick as your point. You see, this is going to be the one. Okay, so the angle 0 is here. You see, this is going to be 0. This is going to be 0. You see, the initial side is going to be the x-axis, and the terminal side is also the x-axis. So what we usually do is we pick a point on the terminal sides. Okay, give us a point on this x coordinates. Pick 1 point.
4,
3,
0.
2.
What's that again? Give us a point located on this side.
Go ahead.
Point
4, 0.
40, yes.
40, yeah.
40, 10, 20, 70. Okay, any point would be fine. The easiest one is 10. Okay, to get these numbers. Okay, it doesn't matter. You can pick anything. Okay, anything you like. But 10 is easier. Okay, so I pick, for example, 10, 40, 50. So I pick the point to be 1 and 0. Okay, so this is it. So what we did is we assume that that point is, so suppose that the point is P is going to be 1 and 0. Okay, quickly, that give you the fact that x is equal to 1. Okay, x is equal to 1, y is equal to the 0, and r would be 1. A square root of x squared plus y squared, okay? That give you 1 again. So that's why it doesn't matter whatever number you take. Okay, it's going to be 4 and 0, 5 and 0. That number would become here and they will cancel out. Okay, so in this case, r, I just write it down so you know it, is going to be 1 squared plus 0 squared. Okay, it's going to be radical 1, which is 1. Okay, or if you get 4, that give you 4. 5, you get 5. Now we are ready to give you those information. The sign of the 0 is going to be, okay, remember the sign is y over r is going to be 0 over 1, which is equal to the 0. So the sign of 0 is 0. Okay, if you want to find the cosine of the 0, cosine was x over r. X is 1. Okay, r is 1. So the cosine of 0 is 1. Okay, if you want to find the tangent of 0, tangent of 0 is you divide y over x. Y over x, okay, and y is equal to the 0, and x is equal to 1. So that gives 0. So the tangent of 0 is 0. Then use the reciprocal to get the other ones. Any question? So let's see if the reciprocal exists. So we go with the cosecant. Okay, that's it. If you go with the cosecant of 0, yes, it's undefined because we get the, okay, the inverse of the 0 does not exist. So it's undefined. Okay, then the secant. Secant of 0 is 1 over, okay, this is going to be, okay, a secant is going to be reciprocal of the cosine,
1
which is going to be 1 over 1, which is equal to 1. That's fine.
tangent and this
And
one.
cotan is going to be the inverse of the, okay, reciprocal of the 0, which is not possible. It's undefined. Okay, it's nice, nice application. You can find the information regarding the 0. Okay, we give you the unit circle table. You don't have to memorize, but it's nice to know. The sign of the 0 is 0, cosine of 0 is 1. We're going to use quite a lot. Then you will get it. Okay, so that's 0. Any question?
No.
We have to do the same thing for the others. Okay, let's see. For the 90 degrees. Okay, I'm ready for the 90 degrees. If you get the data equal to the 90 degrees. So this is it. The terminal side of the 90 degrees is here. So we have to pick a point here. You see, give us a point.
0, 4.
0, okay, 0, 4. 0.4, 0.1 is better. Okay, it doesn't matter. I go with the 0.4 to see that they are going to be the same. And the 0.1 is easier. Okay, so suppose, okay, we go with the P, which is going to be equal to the 0.4. Okay, so this means your X is equal to the 0 and your Y is equal to 4. If you get the R would be the same thing. R would be 4 again. Because R is a distance, R squared, X squared plus Y squared. Okay, now we are ready to give you all the information. The sine of the 90 degrees, the sine was Y over X. Okay, and sorry, Y over R. Y over R, which is 4 over 4, which is equal to 1. The famous, value. The sine of the 90 degrees is 1. So if you want to go with the cosine of the 90 degrees, cosine is X over R. X is 0. That gives you 0. And the tangent you divide. Okay, it doesn't make sense. X, Y. Sorry, YX. We divide YX. YX. That's YX. YX. It's going to be 1 over 0. It's undefined. Usually go with the infinity for this one in calculus. Okay, and the reciprocal of the sine that give you the cosecant of the 90 degree, which is 1. The secant of 90 degrees is undefined because it's going to be 1 over 0. It's undefined, but the cotan of the 90 degrees, okay, the cotan is going to be 0 because it's going to be the reciprocal of this one. Okay, because the cotan is X over Y. You see, X over Y, 0 over 4. You see that's 0 over 4, which is equal to the 0. Okay, so this is going to be the way we are going to give you the 90 degrees. Okay. The other two are going to be the same. I'll just give you the points and then you do it for yourself. Okay. So in the case of the 80 degrees, 180. Okay, this is 180. So you are here. So you need a point here. Easiest point is going to be -1 and 0. Okay, if you get the -1 and 0, then you'll be able to find the information regarding. I write it down for you. This is the sine of 180. It would be 0. The cosine of 180 is a -1. The tangent you divide. The tangent of 180 would be 0. The other one would be the same thing. Okay, so the cosecant is going to be undefined, and then you get those. These three are more popular. Okay, that's going to be 180. And eventually for the 270, as you're locating the angle, 270 is this one. Okay, that's going to be 270 degrees. So you pick the point here. Okay, this point is going to be 0 and -1, or any other number you like. But the x coordinate is 0, and that gives you a -1. So the point P is going to be 0 and -1. So your x would be 0 and the y would be -1. Okay, and we can find the sine of the 270 is going to be -1. Oh, I'm sorry, I need to give you the r. R is 1. Again, we have this in future on the table. It's going to be y over r, which is a -1. It's like the 90 degrees, and the cosine is 0. And the tangent is going to be undefined. It's very much like like the 90 degrees. The idea is important just to know that, using this, the fact that we talk about it, to be able to get these, these, this done. Okay, any question? You have a couple of problems in your book that you see the one that we did over here. We give you the terminal size. These are both special, and the other one, we give you the point. They give you, they put it into different format. Let me just give you that. They are going to give you the terminal side. It's going to be on a special line, if you like. They give you the equation of line. Let me just, are you done with this one?
Yeah.
So you have several problems in your book of this format. So let me explain it to make sure that we are going to be basically interested in the general case, really. And we just give you a point and we want to get it. But it's nice to know this information, to put them together. Okay, so this is similar to one of the problem in your book, but I want to make sure you know it. They ask you to find the exact value. Find the exact value. Okay, exact value of the sixth trig function. Sixth trigonometric. Okay, 6 trigonometric functions. Trigonometric functions of the angle. Okay, of the angle theta. If you see, look at this one. This is new. If the terminal side, the terminal side of the angle, terminal side of the theta lies on, okay, on the line with this equation. On the line with the equation of y equal to the 2x when x is negative. Instead of give you the point P directly, they just put it into this format, if you like. Okay. So basically, this is, you know that this line is line passing through the origin, y equal to the 2x. You can easily draw this line. You see, this is what we have. We have the line that passing through the origin. You see, and we have an angle. We know that the terminal size of our angle is going to be on this one, but when x is negative. So, you start from here. Okay, you start from here, and you have to continue to get to this line, to get to this line over here. You see, that's it. That's the case that you have. Okay, so this is going to be your angle theta. So you are going to be, your terminal size, your angle end up in the third quadrant, if you like. And you know that the equation of this line is going to be y equal to the 2x. Okay. So for the 180 that I checked, remember the 180 end up here. So I pick a point on the x-axis. The 270 end up here. I pick the point over here. So what you have to do, you have to pick a point. As you see, the point on this line over here, and call it the point P, to be able to do the job. Okay. So that give you this line, the position of your point. Okay, can you give us a point? A point on this line. Okay, pick a point on this line that's going to be in the third quadrant.
-1, -1.
-1 and
And 0. Actually, no.
-1
No.
for y.
you know that the point must be on this line. So
Yes.
if you get x equal to
Negative
-1,
two,
what
negative
can be
1 is 2. Well, -2.
No, You see, your point must be on this line. So if you start with the x equal to -1, what's going to be your y?
-2.
-2, yes, -2. You see, you have to pick a point. It's like, it's like those T chart that we have, you see. It's the x and the y equal to 2x. So you want to make sure you are in the third quadrant. So you start with the
And this is
-1.
either
Yeah, you
30
substitute
degrees
the,
or 60 degrees.
okay. That's it. Now we are ready to go and get it. Okay, so just pick a point yourself on, but we have to pick the point on this line. So x is, you put any x you like, any negative x will do it, you get the y. So your P is -1, -2. Any question? That's a suggestion. You can pick x equal to -3 and find it, okay? So that's a suggestion to get this point P. So you need a P. Okay, so this is going to be your point P. So that will tell you that your x is equal to the -1 and your y is equal to the -2. So you are ready to give us the r. So your r is going to be a square root of x squared plus y squared. Okay, so that will give us a -2 squared plus -1 squared. So that make it into the 4 plus 1. Okay, 4 plus 1, which is going to be radical 5. Now we are ready. Any question? So the difference is, you know that your point P must be, okay, the point P must be on this line. So you pick the point that's going to be, okay, corresponds to that line. Now we are ready, we can give you the sign. Okay, the sign is y over r. That's it. So it's going to be -2 over radical 5. But remember, you have to rationalize it. So you multiply that, going to be -2 radical 5 over 5. So that would be your sign. Remember, you cannot leave it with a radical down the denominator. So go with the cosine. Your cosine is going to be x over r, and the x is a -1 over the radical 5. So we rationalize it, we get a radical 5 over 5. Okay, and the tangent is going to be y over x. Okay, that would be y over x. The y is -2, so that's going to be -2 over -1, which is equal to 2. That's the tangent. And quickly, the reciprocal function would give you the result of the other two. Cosecant, you flip this one, negative radical 5 over 2. That is the cosecant. This one, secant. Secant would be negative radical 5. And the cotan, what is the cotan? And the cotan is going to be half. And then we're done. Okay, so this is a little bit different from the others, but it's not a big deal. Okay, I can give a break if you like. We give you a break, we come back, and there's going to be just a couple of more problems dealing with this one. That's good with this x and the y that we have all the time. So what we are going to do is we are going to do a kind of, in this type of problems, point P is given to you, you are able to find the others. So the one that we are going to be interested in is one of these 6 functions would be given to you. Then would like you to find the others. Okay, we did it for the right triangle, but for this type of problem, this is going to be more interesting. Okay, and then we can go over that. We get time to go over your practice quiz to be able to do the quiz. Okay, any question? So we got 10 minutes, then we come back and we continue. And you have any question, we can discuss that.
جرح عفوا.
Okay. So, any question? Now, to get a couple of more problems of this type, there is a modification of this one, or generalization. In your book, they talk about in section 2.3. And that's since we extend the notion of this sixth trigonometric function, sorry, from an acute angle to the to a general, in any angle. So there is going to be a situation that this sine function, as you can see, it depends where that angle is going to be located. This trigonometric function can be positive or can be negative. So it's important to know the position and the sign of this trigonometric function, because the point P can be in the first quadrant, the second, the third, and the fourth. So it depends where this point is or where your angle would be terminated. So the sign of your trigonometric function would be different, and that would be very useful for us. So that is what we are going to discuss, and that would enable us to solve like 2 more problems with these techniques in general, and that would be given to you as one question on the quiz. Okay, so let's check the signs of these angles and the problem associated with that one. Okay, 2.3, what is the signs? Okay, when you generalize it, you may get a positive or negative. What's going to be the signs of trigonometric function? Okay, trigonometric functions. Have some nice problems in this section. All of them would be grouped in just 2 problems. Okay, as we talk about it, you see, you can consider a XY coordinate. So it is going to be an XY coordinate. And you know that it's going to be the first, the second, the third, and the fourth. So if your angle would terminate here, you see the X and the Y, both of them are positive. So remember, the sign was Y over X, the cosine was X over X. So in this case, those angles are going to be positive. Those measurements are going to be positive. So if you are here, the sign of the data is always positive. The cosine of the data would be positive. For the tangent, you multiply these 2 signs together or divide. So the tangent also is positive. Okay, so if your angle terminated into the first quadrant, this is the expression that you see in your book. So this is going to be the signs. Okay.
Yes.
Now, if you are going to be here, if you are here, X is, yes, X is negative, Y is positive. Remember, the sign comes with the Y. So the sign is positive again. But the cosine with the X, so the cosine is negative. Now, positive, negative would be negative. You see, you multiply them together if you like. So if you are going to be in the second quadrant, this is the information that you're going to carry. Okay. If you are going to be here,
Only tangent positive.
no, X is, yes, the other. X is negative, Y is negative. Okay, so this means the sign that start with the Y is going to be negative. The cosine which start with the X would be negative. If you multiply them together, the tangent.
Yes.
The tangent would be positive. Okay, so this is where we get to the second quadrant. Okay, And finally, the last one. The last one, you see the x is positive, y is negative, so the sign is going to be negative. The cosine is positive, and the tangent, you multiply them together, that give you negative. Okay, and this is going to be in the fourth quadrant. That's it.
Yes.
Basically, easy to remember. This is it. The x-axis would be changed to the cosine, and the y-axis would be sine. You see? We got it, when we get to the next chapter, that would happen. So to remember that, think about the cosine on the x, y, sine on the y. Positive, positive, you multiply them together, that give you the tangent. Here, cosine negative, sine positive, you multiply them together, the tangent will be negative. Here, sine negative, cosine negative, you multiply tangent will be positive, and here, the cosine positive, and the sine negative. So that would be very useful for us, okay, from now on, and we're going to use it. Any question? Now we're going to apply it. 2 problems. We give you both of them in the quiz. There you are. The first one is going to be, okay, let's pick the, I have a couple of them over here, but let's see. There was one of them that I can find it. I give you, sorry. Yes, I'll go with this one. And this is the way we are going to give you the problem. Okay, so the problem is going to be, and you have quite a lot in your book, given that tangent of theta is equal to the, okay, is equal to the 1/2. Okay, the tangent of the theta is equal to the 1/2, and the sine of the theta is negative. Okay, the tangent of the theta is 1/2, and the sine of the theta is negative. Would like you to find, okay, find the exact value of the rest. The exact, okay, exact values of all trigonometric function, trigonometric function, okay, trigonometric function of functions of theta. That is going to be interesting to get this number. Okay. So what we are going to do, we have to locate the data. Where is the angle? In which quadrant this angle? You see the solution is going to be?
The third quadrant.
Which one? The third one. Very good.
Third one,
Why?
yes.
Why is in the third one?
Because tangent is positive. Tangent
Yes.
positive
Yes, tangent
is positive
tangent can be positive in the first or the third. Why it is in the third?
because tangent is positive. Positive.
Yeah.
Tangent positive.
Yes, I know that.
Yes.
So,
And sine and cosine positive. Negative.
okay, that's it. Yes, you are right. Now you see the tangent is positive. That's true. The sine is negative.
Yes.
When
And cosine.
you see, so cosine must be negative too, because negative would be positive.
Yes.
So this will tell us that yes, you are right. Theta is going to be in the third quadrant. Okay, so I just explain it. Note that you just give us that we accept that this is positive and sign of theta is positive. So that will tell us that, say, and so cosine of theta must be negative because the tangent is positive. So theta, okay, so theta angle is in the third quadrant, okay, quadrant 3. That is it. We are here. Any question? So that would be useful. When you are here, you see, because you want to use you need that x and the y to get the, okay, to get the sine and the cosine. So now we can say that the tangent of the theta is equal to the 1/2, okay, 1/2, and we know that this is usually equal to the y over x. Okay, if you compare them together, the situation that we're going to have is that the sine and the cosine is negative. So this means, okay, there are different ways to do it. So this means your x is equal to 2 and your y is equal to 2. But since you are in the first quadrant, okay, but theta is in the first, in the third. So this means this x is negative 2 and this y is negative 1. Because when you write it down, you see positive, negative would be positive. So that you want to, so you got to be careful with the tangent to pick these numbers. Okay, any question? So compare them together, but have a look at where the data is. In the case of the tangent, you may have some negative making to the positive. Okay, now the rest is easy. We can find the r. It's going to be x squared plus y squared, which is going to be negative 2 squared plus negative 1 squared. So that gives us a 4 plus 1, which is a radical 5. So we have the r. Any question? Now we can write all of them. The sine y over r. Y is a negative 1 over radical 5. So it's going to be negative radical 5 over 5. Okay, that's a sine. Question? Cosine. It's x over r. X, what is the x? Negative 2 over radical 5. You multiply by radical 5, negative 2 radical 5 over 5. So we have a tangent, the sine and the cosine. Use the reciprocal to get the others. Cosecant. Okay, cosecant is the reciprocal of the sine, which is a negative radical 5. Secant. Secant is the reciprocal of the cosine, which is negative radical 5 over 2. Tangent. Tangent is the, sorry, cotan. I need the cotan. Sorry, I have the tangent. So cotan is the reciprocal of the tangent, which is equal to 2. So you have two choices. You may write the formula right away and change the signs, okay? Or just write at the beginning, especially with the tangent. If it's going to be sine and a cosine, I give you another one, that is not going to be a big deal. You can find out that one quickly. But in the case of the tangent, okay, in the case of the tangent, you got to be careful. Just make sure you pick the, okay, you pick the correct sign, if you like, to be able to get to that one. Okay, any question? We have one on that quiz, and let me see, I have another one. I can give you that one too. That is 2.4. Okay, so this is going to be the, just looking for another one that I make a note to talk about it. Otherwise, we get it right away. See if I can find it. Yeah, this is another one.
2.4.
Okay, let's give you another one. This is similar to what you have in your book. You see another one. They give you this, that if again, I give you the tangent because the tangent is more involved. They give you the tangent, which is -5/4. Okay, this is it. And they tell you, okay, and the terminal, okay, the terminal side of the angle lies, okay, lies in the 4th quadrant. Okay, that's it. Quadrant 4. Then they ask you to find, okay, they ask find sine of the data and secant of the data. It's a type that you have in your book. Again, we stay with the tangent, which is more, more involved, to just make sure you understand it. Okay, so there you are.
It is in the second.
You are in the 4th, you are here. So when you are here, you know that the cosine is positive, sine is negative, and the cosine is positive. So what are you going to, you see this is a tangent, which is going to be -5/4. You know that the tangent is what? The tangent is y/x. So look at this sign. Are you going to use a negative for the 5, or are you going to use it for the 4? You see, as you can see, your x is positive, your y is negative. So this means you have to pick your x to be positive, so x is equal to 4, okay, and your y is equal to the -5. Any question? Different way, to look into it. This is it. You are in the 4th quadrant. Remember, this is cosine, this is sine. This is x, this is y. That's it. X, y. So you have -5/4. It can be, you can write this one as a -5/4, or you can write it as a 5/4. But you know that this is x must be positive, y must be negative. So you pick x equal to 4, y equal to the -5. Okay, so this is the way you check these numbers. Any question? The rest is easy. You find the sign. What's the sign? Remember, the sign is y. Oh, I'm sorry, I have to find the r. What's going to be r? Let's find r first. So what's going to be r is equal to the square root 4 squared plus a -5 squared. 4 squared would be 16, and that would be 25. That gives you radical 41. Okay, so you have to find the r first. Any question?
No.
Now sine is sine start with the y over r. So the sine of theta is going to be -5 over radical 41. You have to rationalize it. It's going to be -5 radical 41 over 41. That's the sine.
Fine.
We need a cosine because they asked for the secant. Cosine. Cosine is going to be x over r. The x is 4 over the radical 41. So it's going to be 4 square root of 41 over 41. This is a cosine. As for the secant, secant is reciprocal of the cosine. Secant, reciprocal of the cosine. I just write it down, remind you. 1 over cosine of the theta. So that's going to be radical 41 over 4. And then you're done. Okay, so this is what you are going to do in this section. When we get to the next chapter, we change it to the unit circle disk, and it's going to be the same procedure. It's easier, but you get quite a lot of problems. Just make sure you don't miss these signs, okay? Especially when it's a tangent. Otherwise, it's not going to be difficult. Okay, so that's a 2.3. There is one more, okay, a couple of more things to do with this one, but I like to go to that practice one first, or any question you have. Then we come back. 2.4 is some special identity of the trigonometric function. We don't want to use those identity for this quiz. So we are going to give you this one after the quiz. If we get time, I go over it. But first, let's check those practice quiz. Okay. Any question, anything especially you want to explain before going to that practice quiz? So we give you the quiz up to the 2.3. Okay, 2.3. 2.4 is easy, but we collect the assignment on that one next time. Are you ready to go on the practice quiz? To see, so you have to take on one is going to be yours. That I explained that practice quiz and or any question you have. I want to make sure that you catch up with what we have. So the practice one is the one that I posted for you. Let's see if I can bring it here to show you. Just the take on one. That is, I put it. Okay, I left it somewhere that I have to look at it. Bring it here for you, and then we go over it. So, yes, I have it here. Okay, so we give you 6 sets of questions, and these are the topics that I'm going to go over it. Okay, so the first one is easy, but we work with these type of ideas. So we are going to give you one question, just giving all these together. We put them together as one question. Okay, so just quickly remind you the answers if you want to check it for yourself. Okay, so these are going to be measurements other than the degrees that we have. So this is a practice. Okay, your practice quiz number 1. You do the take-home one. Okay, so the first one, they ask you to perform as is indicated, the first one. So this is it, the first one. we want to add, okay, so this is it. You want to add 12 degrees for the 2 minutes. You add it to the 55 degrees and 49 minutes. That's it. Remember, we add them together first, and then if we have to simplify it, we simplify it. So 2 and 9 would be 11, we get 1. So that give you 9, 7, and this is going to be 6. So it's going to be 69 degree and 91 minutes. You know that you have to change the 91 units,
Yes,
okay?
6.
So it's going to be 1. So it's going to be equal to 68. Okay, it's going to be 68 degree but 31 minutes. Okay, because 91 is 60 plus 31 minutes. 60 minutes is going to be 1 degree. So we add it to the other side. That is the first part. Any question?
No.
The second part, the subtraction. So that was the part 1. Part 2, you want to subtract 82 degrees. Okay, 27 minutes, subtract minus 35 degrees and 39 minutes. That's it. So you check to see if you have to do something first. 39 minutes out of 27 is not possible. So you have to borrow 1 from here. Okay, you borrow 1 degree, it's going to be 60 minutes. You add it to the other parts to be able to do it. Okay,
81.
so 81 degrees. So you change this one into 60, that give you 87 minutes. And this is going to be 35 degrees and 39 minutes. Now we are able to subtract it. Okay, that give you 8, 4, and this is going to be 6 and 4. So that give you 46 degrees and 48 minutes, and we're done. Any question? That is the first operation that we have. Okay, these are in section 3 point, I think. Oh, that's a 1.3 or 4. Okay, that's the first one. And number 2, you want to convert. Okay, remember we give you, this is in the form of the DMS, okay, the degree, minutes, and the seconds. We want to change it to the degrees in the decimal form. So this is the way we're going to do it. The first one is 73 degrees. Then 40 minutes, and 40, okay, 40 seconds. Okay, so you know that in order to change it to the decimals, we have to make it
Divide.
small, if you like.
Divided.
They have to divide it, yes. So it's 73 degrees, 40 minutes, and the seconds. So this is going to be 73 plus, this is going to be 40 over 60 to change it to the degrees. And this is going to be 40 divided by 3600 degrees. Okay, so this is the way you are going to see it. And you can divide it using, okay, your calculator if you like. But I have the numbers, so I give you can check it for yourself. So this is it. So you should get 73 plus 0.666, and this is going to be 0.011. The result is going to be 73 degrees and 677. So that's the first part. Any question? So it's not going to be difficult. And that's the first part. I give you the answer for the second one. You can check it for yourself. Okay, so the second part is 98 degrees, 22 minutes, 45 seconds. Okay, you can check this one, which is going to be 98 plus, okay, I have 0.367 and the 0.013. If you put them together, that should give you 98.38 degrees. Okay, these are going to be used in application problems, so you want to make sure you remember it. Okay, any question? That's number 2. Okay, so the degrees, minutes, and the second is given. We change it to the decimals. So that's number 2. Ready for number 3? They are easy. We can take care of this quickly. The other way around. So in the decimal form would be given. This is number 3. Okay, number 3. In the decimal is given to you. You want to change it?
Yes.
You want to make it bigger, you multiply it.
Yes.
So the first one is 18 degrees. Sorry, 18.255 degrees. Okay. So you have to expand it.
Yes.
Okay, so this is going to be 18.255. We write it as, okay, we start with the 18. That's going to be 18 degrees. So then 0.22. Okay, so that's going to be 0.255. Okay, that's going to be degrees again. Then we change is 18 degrees plus 0.255 times. Okay, we times it by 60. But we change it to the minutes. So if you do this, this would be 18 degrees plus, that give you 15.3 minutes. So we pull out the 15. Okay, so this is going to be, okay, so that's going to be 18 degrees, 15 minutes, and the 0.3. You know that we change this one into the second by multiplying by 60. So the final answer is going to be 18. Okay, that's going to be 18 degrees, 15 minutes, 3 times 6, 18, and 18 seconds. So that's going to be the one. Not difficult, but you know, we have it.
Yeah.
And we have to do it. Any question?
No.
I'll just give you the answer for the part B. You check it for yourself. Okay, what's part B is 29. Okay, 29.411 degrees, thousandths.
Yeah.
If you do it, it's going to be 29.
Degree plus
I write down just the final answer, so check it. 24 and 40 minutes, you see. Let's do the same one, get the same correct answer. Okay, any question? So that's these preliminaries that we have. Okay.
Yeah.
Now we would like to start working with some expressions, just adding, subtracting. So that is the idea of number 4. An expression is given to you. This 30 degrees, 45 degrees, the one that we talked about it the other night, you need to use it. You can bring it to the quiz, I don't mind. Okay, 30, 60, 45, 90, these the numbers that we did so far. So you may have to use it when they say exact, no calculator, okay? So I don't mind, you can bring it, then I give you the unit circle, the chart for your next, for test number 1. So you have all this information. You don't have to memorize it, okay? But your algebra is going to be important. Some people, they miss the algebra of this type of function. Okay, so they want you to find the exact value, okay? Find the exact value. Okay, you substitute, there's going to be radical something, you take care of it. So the first part is the 5 sine of the 30 degrees. So this means 5 times the sine of 30 degrees, order of the operation. You find the sine of the 30 degrees first, you multiply by 5. It's like 5y. Okay, so the solution is going to be, it's a 5 sine of the 30 degrees is equal to the 5 times the sine. Sine of the 30 degrees from your table, that give you half.
half.
So that give you 5 half. Okay, so that's the exact value. Any question? So it's a direct substitution, but we want to get to know the algebra, especially if there's going to be any power like this one. Sine squared. Sine square of 45 degrees plus 4 cotangent. Cotangent of 45 degrees. You have the information. The sine is radical 2 over 2. And the tan and the cotangent of 45 degrees is 1. So you just substitute. So just remind you from your table, the sine of the 45 degrees is radical 2 over 2. Okay, and the cotangent of the 45 degrees is equal to 1. So you are going to substitute. Okay, so this is going to be equal to sine squared. You see, order of the operation, sine first, then you square it.
Yes.
So it's going to be radical 2 over 2 all squared. Okay, plus 4 times the cotangent times 1. Radical 2 squared would be 2, that give you 2, 4. And this is going to be 4. Okay, you simplify the 2 quarters as a half. 1 half plus 4, 4.5, or 9 half, the final answer.
Yeah.
Okay, you are going to get more involved with this type of ideas in future, not now. Okay, so that is going to be the case. And we give you one problem, it would be a couple of parts, just those kind of application problems, okay? And not difficult, but we want to make sure you know it, to read this problem and answer it. This number 5 is easy, like the one that we did with that, okay, flagpoles. So that is a number 5.
Mhm.
You see the number 5? The angle of elevation, again, is the one to the top of the building is 72 degrees from a point 200 yards from the base of the building. We want to know how tall is the building. Okay, so this is it. You get the idea. You see, this is going to be the building, and you're looking at it from this angle. Okay, that's it. The angle of elevation is this one, which is a 72 degrees. And you are to the base of the building. Your distance to the base of the building is 200 yards. Okay, so you would like to know how tall is the building.
Oh, yes.
So you just would like you to read it, okay. It's not going to be a difficult problem, but make sure you read it correctly.
We will find tangent of 72.
That's it, yes. You just think about which one is better.
Yes.
So it's like, you know, this is X, if you like, and this is Y with those formula that we talk about it, you
Yeah.
see. That's going to be the case. So the best thing to do is tangent, because the tangent would give you the opposite side over the adjacent. You don't have any hypotenuse, so that's why you cannot use the sine or the cosine. Okay, so you argue that the tangent of 72 degrees is going to be equal to the y over x. Okay, your y is missing, your x is 200. You cross multiply, so your y is going to be equal to the 200. Okay, 200 tangent of 72 degrees. Okay, then you have to use your calculator to get these numbers. Okay, with my calculator is okay, so you know that you just check the tangent. This is going to be the tangent 72. Okay, this is going to be the tangent. Then you want to multiply by 200. Multiply by 200.
Mhm.
That gives something like this is it, 615.5. We call it 616. Okay, so not a big deal. This is going to be the 1 yard. Okay, so you know, we just give you one of these type of problems. Just be prepared for it. Okay, any question?
No.
Now, number 6 is interesting. There is something about it I want to explain. Is the number 6? Cosine of 15 degrees is given to. Cosine of 15 and the 75 degrees are popular, and you will see it a couple of more times during this course, and they are also popular in calculus. So let's see what's the idea. Number 6.
Mhm.
Number 6 they give you is, you know, they ask if cosine of 15 degrees is going to be equal to radical 6 plus radical 2 over 4. Okay, they ask for the exact value, means no calculator. Find the exact, okay, exact value. Okay, the one that we have, the first part is the sine of 75. Sine of 75 degrees to get these numbers. Now, you see, you can write, you know, this is the sine, the cosine. You can write it down as we give you the formula. Remember that would be x over r, and then find the sine. But there is something about these angles that we may, you know, I think we didn't talk about it. And we are going to see it in future. They are very important. You see in the right triangle, if you are going to be in the right triangle, you see, if this is going to be a right triangle, that's your 90 degrees. That's your 90 degrees. Suppose this is 75, and you know that it's going to be 15. They are complementary angle. If you add them together, that give you what? You add them together, that give you 90 degrees. So for this type of angle, you see, look at the, if you find the, for example, if you find the, if you want to find this cosine of the 15, you see the cosine of the 15 would be
The sine.
adjacent. You see, the cosine of the 15, for example, is going to be adjacent sides over the hypotenuse.
Yes.
But if you find the sine of 75, it's going to be the same thing. So if two angles are going to be complementary one, the sine of one of them is cosine of the other one.
Yes.
And the cosine of the other one is going to be the sine of the other one. They call it co-functions. So we can use that type of ideas, or you can find it, you know, it's not a big deal, but and that's the idea of this problem. So that's an excuse just to remind you that that formula. Okay, so I give you a remark, then I'll do it. So this remark for your information in case we missed it. Okay, so the answer is the sine of, you see the solution, simply the sine of 75 is the same as the cosine of 15, which is a radical 6 plus radical 2 over 4.
Yes.
If the sum of two angles happen to be 90 degrees, we call them cofunctions. Cofunction means the sine of one of them is cosine of the other one. The cosine of one of them, you see, is going to be sine of the other one. The tangent of one of them is cotan of the other one. So that would be helpful. We are going to talk about this one in the next chapter quite a lot, but it's good to know it, to get these numbers. Okay, so and that is the idea in order to get this number. So the sine of 75 is just radical 6 plus radical 2 over 4. That's the first part. I'll do the second part, that I give you a note. The second part, they ask for the secant of 15, which is easy. They ask for what is the secant of 15 degrees? You know that the secant is the reciprocal of the cosine,
Cosine. Yes.
is 1 over cosine of 15. And you already got the cosine of 15. So you flip it. Yes, I just show you. It's a radical 6 plus radical 2 over 4. So that gives you 4 over radical 6 plus radical 2. You're not done, because they ask you for the exact, and you cannot, stay with the radical down the denominator. You have to rationalize it.
We will, yes.
You multiply the top and the
Multiply
bottom
with
by,
yes, radical 6, negative radical 2.
yeah, that's going to be the conjugate. Okay, so it's going to be, you multiply the top and the bottom by the conjugate, we call it. Okay, yes, you are right. This is it, radical 6 plus radical 2 times radical 6 minus radical 2. Now, the top one would be radical 6 minus radical 2. The bottom one, you know that this is a special product. Radical 6 times radical 6 would be 6, minus radical 2 times radical 2 would be 2. Remember, it's going to be a square of the first one minus the square of the second one. So, there was a 4, I missed it. 4 times. 4 times. Okay, now the bottom one would be 4. So that would be 4 radical 6 minus radical 2 over 4. These two will cancel out. So we get the radical 6 minus radical 2. So this is going to be the secant of 15 degrees. This is one of the problems in your book. So I brought it here to explain it for you, to get these numbers. Okay.
Hey, I have a question though. So is this the minimum amount of work that we are asked to do? Like we don't have to do more than this?
No,
This
no,
is
no. That's it. Yeah.
Okay, cool.
That's it. Yeah. But when they say exact, you must make sure you don't use your calculator. That's it.
Oh yeah, I know. I just mean for like how much work we have to show.
Oh, yeah. Yeah, that's one. Okay. Any question? So, we get to that cofunctions later. We don't need it now. So let's get to the number 7 is the one that we teach. Okay. We want to find the exact value of the 6 trigonometric function of the 90 degrees and 180. Okay, I did the 90 degrees. I did both of them in your, okay. So I just rewrite it, just give you a hint, then you check the lecture notes that we have. Okay, so number 7, and they ask for the 6 trigonometric function of the data equal to the 90 degrees and the data equal to the 180. And that's exactly what we did. Okay, I just remind you to check it. Remember, we need a point for this one. The point was something here, which is 0 and 1. So the point P is 0, 1, and you write it down. And over here, okay. So we pick this point, which is equal to the -1 and 0. So this is going to be -1 and 0. So check your lecture notes tonight, and you get those. Remember, this is x0, y1, r1, and this is x -1, y0, r1. So check it in case we ask you this one. Make sure that you are ready for it. Okay, so that's number 7. 8, 9, 10, those, and 11. Is that the one? Okay. Are you ready? 8, 9, 10, these are the ones that we talk about tonight. Number 8, a point is given to you. See, that's it. A point is given. We have an angle whose terminal side passing through these points. So these are going to be the point associated, if you like, the point associated with the given angle, and you want to find the 6th trigonometric function. Okay, so we do this one. I think I did this one, -3 and 4. That's the one we did tonight. So we do the other one. I can give you all the information so that you can have it. So that's number 8. Okay, so I do the other one because we did the, yes, we did the first one. So we do the second one, part B. At the point P is equal to 2 and -3. Okay, this is your point. So you are going to be in, okay, 2 and -3. X is equal to the 2, and this is going to be -3. So we are here in the, okay, in the third. You know, automatically you will get all those information that you need. You know that the
Only
cosine is
cosine.
positive, cosine is
fine.
positive, yeah. The other is going to be negative. So remember, this is the way we do it. This is P is equal to the 2 and -3. So that will tell us that the X is 2, Y is a -3. You have to find the R. R, square root R, 2 squared, plus a -3 squared, 4 and 9, 13. So that's R. Now we start writing those 6 trigonometric function. Start with the sine. Remember, this is sine, if you like. This is sine, this is cosine. So the sine is going to be y over r. What is y? -3, radical 13, rationalize, -3, radical 13 over 13. So that gives the sine.
Cosine
Okay, cosine,
over R.
x over
R
x over r. X
2,
is 2
2 over 15.
radical
Radical
13. So that gives it 2 radical 13 over 13 as a cosine. Tangent, you divide y over x, negative -3/2. That's the tangent. Make sure you know,
Yeah.
remember the formula and substitute to get it. Okay, use the reciprocal to get the others.
Yes. Radical 30 over
So the first one, cosecant,
cosecant radical 13 over
you better use this one. So it's going to be negative radical 13 over 3. That's a cosecant.
cosecant cotangent
Secant,
cotangent
reciprocal of a cosine. So this is going to be radical 13 over 2. That's a secant. Cotan, reciprocal of the tangent, which is a negative 2/3. So that's it, the 6th trig function. Any question? So that was the main idea of section 2.3 that we did tonight. So we give you one, you have the one on your take home one to practice for all of them. Okay, any question?
No.
So that's number 8. And number 9, that tricky one, that one of these form would be given. They ask for the one of the function would be given. They ask for the others. That's a number. Okay, that's a number 9. And one of these 6 functions would be given. Then you have to find the other for us. Okay, so that's the idea. And there are 2 cases. They may give you tangent or they may give you sine or cosine. Okay, so this is going to be number 9. Okay, in number 9, we want to find the exact values of the trigonometric function with this condition that the first part is a sine of the data is given to you. The sine of the data is 12 over 13. And there is a condition. The condition is that the data is in, okay, a second quadrant. So it's going to be in the second quadrant. Quickly identify it so that be able to get the
means the
in
cosine
order.
is negative and tangent
Yes.
negative.
Yes, that's correct. So remember, this is going to be cosine. This is going to be the sine. So we are here. Okay, we are here. So the sine is positive, is already given. Cosine is negative, and the tangent is negative. Okay, so the sine is positive. Just in case we need it. The cosine is negative, and the tangent, you just need these two. And so we are going to get the formula for the sine. Okay, the sine of the data is equal to 12 over 13. Okay, 12 over 13. We know that the sine is going to be what? It's going to be y over r. Okay, since the sine is positive, so that will tell us that what? Y is
Y.
equal to 12.
R
R is equal to 13. Okay,
we can find x.
so we have to find the x.
Yes.
How are we going to find it?
X um,
Yes.
R square
Yes, that's correct. You see,
Five.
that's x.
R
It's
square
5. Okay, so the formula is going to be what? X squared plus y squared equal to the r squared. Okay, so x squared is the missing one. And this is going to be 12 squared, which is going to be 13 squared. So that's x squared, 144. And that's 169. So the x squared is going to be 169 minus 144, which is a 25. You see, x squared is 25. So what is x?
5.
Yeah, it's going to be 5, but remember the cosine is negative.
Yes, negative.
So you have to make
Negative.
this one to be -5.
Mhm.
Okay, remember this in this type of problems, the x and the y are coordinates, so can be positive or negative. In the other application problem that we use, we're talking about the length, okay, side length of a triangle. So in those cases, it was always positive. Okay, make sure you know the difference and then you're not going to miss it. Any question? Because we already determined the cosine is negative. So remember the cosine is x if you like. You see, that's x. So that's why you pick x equal to -5 to be consistent with this one. Now we are ready to get the cosine. So it's
Cosine.
happened, for if the sine and the cosine would be given to you, you have to get this
Yes.
justification here. Be careful.
X
Okay, so the
over
cosine is
R.
going to be x over r. So it's going to be -5 over r, which is 13.
13.
Okay, so you double check, you find out this is negative, so it's correct. Okay, so this is the sine and the cosine. Now the rest are going to be easy. We get the
Wow.
tangent. Okay, we divide these two or just the y over x. The tangent must be negative, and it is negative because it's going to be -12 over 5. Okay, and then we get the reciprocal to get the others. So the cosecant is going to be, so the cosecant is the reciprocal of the sine, which is 13 over 12. Okay, the secant is the reciprocal of the cosine, which is -13 over 5. And the cotan is the reciprocal of the tan, which is a -5 over 12. And then you're done. Okay, so be careful. Don't miss the signs of this, this problem. Otherwise, not difficult.
Mhm.
Okay, any question?
Mhm.
So that's that. There are two cases. They may give you the sine or cosine, or they may give you the tangent. These are the two possibilities that we are going to have. Okay. So ready for the next second part? Just checking this one. That's the second case, that possible case, tangent of theta. The tan is given is a 3/4. This is like the one that we talk about it, but they give you this information that the sign of the theta is negative. Remember we talk about this one.
In the third quarter.
It's going to be in the third because the tangent is negative. Tangent is positive. Sine is negative, so you need another negative to make it to the tangent to be positive. Okay, so the location is going to be, we said that the tangent is positive and the sine is negative. You know that we multiply the sine and or we divide the sine and the cosine to get the tangent. So this must be -2. Okay, because I'm sorry, this must be positive because positive negative would be, oh, this is negative. This is positive. Sorry, oh, I made a mistake again. Negative, negative, negative. It must be in the third quadrant, and that's going to be the case. Okay, there you are. So we are here. Okay, as you can see, the x and the y must be negative because that's a cosine. That's going to be the sine. Both of them must be negative, and that make it interesting over here to be careful. So we know that the tangent, okay, the tangent 3/4 is equal to the y over x. Okay. When you compare it, we usually take the y to be
We'll,
3x4,
find
but you have to take the both of them to be negative. Okay. So
We'll find out.
y is a -3 and the x is -4. You know that because we can rewrite this one as what? Rewrite it as a -3 over -4. You see, if you write this one as a -3 over -4, negative would be positive, but it would be consistent with the definition that we have. So it was, you know, it's supposed to be -3 and -4. And the reason that's going to be 3/4 because the negative is positive. Okay, so don't miss it. This is important. Any question?
No.
Now we can find the R easily, 9, 16, 25. So R would be 5. Okay, so the R would be 9 plus 16, which is equal to the 5. So we have the X, Y, R, and then easily we can write all the functions. So don't miss it. Yes, the signs is important to pick the correct one, especially when you go with the tangent. Okay.
Yeah.
So there you are. The tangent is going to be. So I'm going to the next part to give you the result. Okay, are you ready? So I take this x and the y together. So that's why I write down quickly. So x is, you're not done. X is a -4. Y is a -3. And the R is 5. Now we can start writing all the functions. So the sign of the data is going to be y over r, which is -3 over 5. So that's a sign. Cosine is equal to, okay, x over r, which is a -4 over 5. Again, we already got the tangent. I just repeat it again. The tangent is a 3/4 y over x. Okay, that's it. Now we get the reciprocal to get the other 3. Okay, reciprocal of a sine is cosecant. So that gives us a -5/3. Reciprocal of a cosine would be secant, -5/4. And we have a cotangent here, which is going to be 4/3. And we're done. Okay, so it's a typical problem we want now. And getting one on the, okay, on the next. And there are some other method to do this type of ideas. We are going to learn it, but we always prefer this method because it's much easier. We use it in calculus too, quite a lot. And there are a couple of sections on that course dealing, we do something else, but at the end, we have to find this, and this is the quickest way to do it. For that, we get to there. I'll give you this example again later on. Okay, so that was question number 9. Okay, number 9, that will take us to the question number 10, which is solving a triangle. Remember, solving a right triangle means
Oh, yes.
you have to find the 3 side length, okay, and 3 angles, or just no, 2 angles. So that would be number 10. It's the one that we talk about today, section 1.5. That's 1.5. We give you 1, but it's going to be 2 parts. Okay, we want to solve each right triangle. Right triangle means find we give you the, we give you the graph of the triangle. Just make sure that, you're just using correct notations, okay? So otherwise the ABC would be of this format, but I'll give you that right triangle and explain it for you. Okay, so this is the notation that we are going to use. You see, that is going to be used for the quiz too. So we usually go with the A here, and the B, and the, okay, and the C. That is going to be the case. And this is going to be the angle alpha. Okay, so if we don't give you the graph, this is what we mean. Okay, but we give you the graph, just make sure that we have no difficulty. Okay, so the case 1. The case 1 alpha is given to you, the angle is given 50 degrees, and the side is C, 27 feet. Okay, the hypotenuse, if you like. So that is going to be case one. So in a case one, this is where we are. This is a 27, so the A and the B is missing, and the angle of 50 degrees. Okay.
Yes.
So the easy one is to find this one.
Yes.
You know that this is going to be out of, this is 50, 90, that give you 40. So I'm going to call it beta. It's going to be 90 minus 50, which is 4. Remember, you have to write it down. You have to give us this angle. Some people, they miss it
That's the difference.
because solving means 3 angles, okay? 3 side length, if you like, okay? So the angles, one of them is 90 degrees. You have to find the other ones. Okay, so we are done with the angles. A, B, C. Okay, any suggestion to find the
Use tangent?
no, tangent is no good.
No, sorry, yeah.
Sine
Yeah.
of the of
You can use either cosine or sine.
Yeah, yeah.
Now that we have
Cosines, yeah,
angles.
sine of 50.
cosine. So I go, I have the number for the sine because the hypotenuse is given. See, I go with the sine. So the sine is going to be the opposite over the 27. Okay, use a cross multiplication to get the B. So the B would be 27 sine of 50 degrees. Okay, then use your calculator to get this number. And you have the 2 digits only. So if you use your calculator, you can check it. It's going to be almost, I picked 21. Okay, so B is going to be 21 feet. Okay, that's going to be B. And then you have to find the A. Okay, you can use Pythagorean identity or you can use cosine. It's easier
Minus B to 4.
because, yeah, it's cosine is easier because the cosine give you adjacent side. Okay, it's going to be A over 27. So that would be easier. So this is going to be the case. So the A is going to be, we cross multiply, that gives us a 27 cosine of the 50 degrees. So if you check this one with your calculator, that should give you 17. So the A would be 17 feet. Okay, check it, but it should be fine. So there you are. We got the length of all the sides and we have the angles, then we're done. Any question? So this is case one. The case that we have one angle and they may give a different side, but in this case they give you the hypotenuse and be done. Okay, quickly checking the second one. Second one is the one that they give you 2 sides. Okay, are you done with this one?
Yes.
I have to go to the next page to give you that second case. 2 cases. Okay, so the second case, that's a 10B. And we have that A is equal to the 30.5 feet. Okay, and the B is 45.7 feet. That's it. No angles in this case. So that's going to be the one we call it case 2. Okay, this is it. So the A is here. And this is going to be the B. 44.7. Okay. This is all you have. Okay, so you have to find the C and you have to find the alpha. Okay, any suggestion?
Tangent alpha. Tangent.
Yeah, we can go with the tangent
Yes.
because we have the opposite and the adjacent. Okay, that would be quick to find it. Yes. So we go with the 10. Okay, the tangent, that's going to be y over x. In this case, is going to be 45.7, and this is 30.5. Okay, if you divide it, that give you something like 1.498. Okay, and in order to get the, I'm sorry, it's alpha. That's one. Yeah, I just wanted to show that, you have to use the inverse to get this one. Remember, so the alpha,
150.
I just want to write it down so you know that's going to be 1.498. Okay, how much do we have? No, it's, let's check it. Okay, so this is, you go to the second and the tan inverse. Okay, the number is 1.498. So the angle is 56.27. Okay, so we have to go with the 3 decimals, 3 digits if you like. It's going to be 56.3. Okay, 56.3. 56.3. Okay, this is going to be one. That's it. 56.2746, etc. Okay, so just make sure you locate the place that you have to go to get that inverse function, if you like, to get the alpha. Okay, any question? We have the alpha. We can easily find the other one.
Yes.
So the beta is going to be 90 degrees minus 56.3. Okay, so that gives us 33.7 degrees. Okay, so we are done with the angles. We have to find the hypotenuse so we can
Yes.
see.
C.
Okay, any suggestion?
C squared.
Yeah, we can use the Pythagorean identity. C squared is the sum of the other two. Okay, so C squared is equal to the 45.7 all squared plus 30.5 all squared. Okay, if you use your calculator, simplify it. This is what I got. I got 18.74. I take the square root. I arrive at, take the square root of this one. I just want to show you how we round it. Okay, so this is the square root. We go with the second, the square root of 3018.74. You see, this is what you get, 54.94. Okay, we have to go with those 3 significant digits, if you like. We run that, that give you 54.9. If you run that give 55. So the way we write it down is, it's going to be 55, but 55.0 for it. Because they're just using 3 digits. They're using 3 digits, so you have to follow the same procedure. And you put the 0 here to show that you did rounded. That's, operation. If you write 55, even be accepted. This is the way you see the solution in your book. Okay, so that's solving the. Okay, so the last one. There are much more to go with this one. I don't have the number for this one. We just leave it. We give you something straightforward. Just this is the one that you have to use. Get your information. Okay, it takes a little more time. We don't give you this one on the okay, on the squeeze pad, just because the angle is not difficult, but the angle is 34 degrees and the 30 minutes. Okay, that's one. So, and the C is given
Compare.
to you. You see, and it's in inches. You can change it to the decimal number if you like.
Yes.
Okay, and then you just keep
We
going.
divide it.
You know, you have to
60.
divide it
Yes.
to
Add it.
get this number. So I'll just leave it for you to do it. Okay, but otherwise this is going to be, okay, this is going to be the alpha. It's like the first case that we have, 12.7. Okay, and so you can use the sign, for example. If you use the sign, so these are missing. Okay, but we have the hypotenuse over here. So for example, we can use the sign of the
Fine.
alpha, which is going to be equal to the b over, okay, b over 12.7. Okay, 12.7. And then our b would be what? Our b would be, v would be 12.7. Then the sign of the alpha. Now what's going to be our alpha? Alpha is 34, okay, degrees and 30 minutes. And I put it somewhere. I just wanted to see how we calculated this number. You see, you can do all the operation at the same time. So this is going to be, you know that you have to divide it. So this is how I did it. I want to find the sign. You see the sign? The sign of what? This is 34 degrees. You see, this is going to be 34 degrees plus, okay, plus, remember, you have to divide this one.
Or
It's going to
60.
be plus 30 divided by what?
No, 60.
Divided by
60.
60. You better put the parentheses so that probably that would give you an error. Oh no, that's the one. Then you multiply by 12.7 to get the, okay, to get the final answer. Okay, so it's going to be 7.9. You know, that give you the result. Okay, you better double check it, make sure you get right. So if you this is it, so that gives 7.19. The one that I have 9 something. Maybe you have to know. Oh no, that's it. That's 7.19. Okay. Any question?
No.
So you know the 34 degree and the 30 minutes, you know, we just divided by 60. So I'd like to quickly, if we keep just we have a couple of minutes, just give you the answer to the last one. Make sure we have no difficulty. And we're not going to do as many questions on this practice one, but those are the topics. But the topic is going to be the same. I make 6 questions of this. Okay, you have the take home one, just make sure you get it. So this question number 11 is like the other one that we did. Okay, so what's 11? This is it. You see, you have a 13.5 meter fire truck ladder is leaning against a wall. You see, we have, this is a wall, and this is the ladder. Okay, this is going to be the ladder, but the length of this ladder is 13.5 meters. Okay, this is it. Elevation angle is this one. This angle, if you like, the alpha, is equal to the 43 degree and 50 minutes. Okay, that's going to be the one. So this angle is given to you. What they want is, they want to know they want to find this length, if you like. Okay, this is going to be the one. They call it find the distance d. Okay, find the distance. What's that? Find the distance t that the ladder goes up the wall. I say this is going to be the one, and they put it on the. This is the one. This is the
sine of alpha.
yes. The sign will do it. Okay, because the sine would give you the opposite side. So the sine of alpha is equal to the d, if you like, over 13.5. Cross multiply. So that give a 13.5. The sine of alpha, the same thing is going to be 13.5. The sine of the angle is 43 degrees and 50 minutes. The same that I did for the other one, that should give you 9.35 meters. So this is going to be how far the ladder goes up, if you like. Okay, so you have a similar one in your okay in that take-home one, so you should be able to do it. Okay, so I send you an email again. So the problem is going to be 2 is going